Hello dear students, welcome to the lecture on calculus and linear algebra. In my previous lecture video, I described briefly about what is meant by matrices, types of matrices, matrix operation, how to find the inverse of a matrix, and also how to find the rank of a matrix by converting the given matrix into echelon form by using elementary row operations. So in this lecture video, we'll discuss few example problems based on the echelon form. So now I'm going to discuss about the problems to find the rank of a matrix. Example number 1. Find the rank of the following matrices by the elementary row transformations. So the elementary row transformation, in the sense we have to perform row operations to get a echelon form. So after getting echelon form, we can find the rank of the matrix. So here the given matrix is 4 cross 3 matrix. So 4 rows, 3 columns. So the matrix A is given like 1, 2, 3, 2, 2, 3, 5, 1, 1, 3, 4, 5. So now we'll do one thing. I'm going to denote the first row of the matrix A as row R1 and the second row as row R2 and the third row as row R3. So now I'm going to apply the series of elementary row transformation. The first thing is I want to convert the first entry of the row R2 and row R3 as 0. So for that I can make an operation like R2. The row R2 implies that R2 minus 2 times of R1. I'm going to multiply 2 for the complete R1 row. I'm going to subtract the same thing with the row R2 to get the value of R2 row. Next is again same thing. To convert this first entry of R3 is 0. I'm going to subtract R3 with R1. So I can get 0 here. So the operation like this, R2 implies that R2 minus 2 R1, R3 implies that R3 minus R1. So after applying the transformation, so I'm keeping the first row R1 as it is 1, 2, 3, 2. I'm doing operation with respect to row R2 and R3 only. So if I apply the operation here, that is R2 implies R2 minus 2 R1, the first entry will become 0 here. Again 3 minus 4, I'll get minus 1. 5 minus 6, I'll be getting minus 1. 1 minus 4, I'll be getting minus 3. I'm just multiplying 2 with the R1 row, subtracting with the R2 row. So I got this row 0, minus 1, minus 1, minus 3. Similarly, I want to convert the first entry of R3 also 0. So for that, I'm going to subtract R3 with R1. So what I'll get 0, 3 minus 2 will be 1, 4 minus 3 will be 1, 5 minus 2 will be 3. So this matrix I got it. So actually I want to get an echelon form, right? So to get an echelon form, I can make the complete last row as 0, right? I can make the complete last row as 0, or I can make only the diagonal entries. I can get the upper triangle matrix also. I can get it to get an echelon form. So now here we can see that by adding these two rows, R3 implies that R3 plus R2 if I make means I can make the complete R3 row 0. So now the next operation is I'm going to convert R3 complete row as 0. By the operation R3 implies R2 plus R3. So I'll be getting 1, 2, 3, 2, 0, minus 1, minus 1, minus 3. I'm keeping R1 and R2 row as it is. I am doing operation with respect to R3 row. So adding R2 with R3 from the previous matrix, I'll be getting 0, 0, 0. So according to echelon form, the first entry of the non-zero row must be 1 always, right? So but here minus 1 is there. So to make this one as plus 1, I'm going to multiply this complete row with minus 1. So I'll be getting 1, 2, 3, 2, 0, 1, 1, 3, 0, 0, 0. So from this matrix we can say it is an echelon form having 2 non-zero rows. So hence the rank of the given matrix A will be 2. One more example, the given matrix is 4 cross 3 matrix again. The matrix is A is equal to 0, 2, 3, 4, 2, 3, 5, 4, 4, 8, 13, 12. So now the first thing is to make the operation easier, I'm going to interchange any two of the rows. So I'm going to interchange the R1 row with R2 row. So always we know that in the echelon form, the first entry of this first row must be 1 always. to make that one also, it will be very useful, right? So I'm going to interchange R1 with R2. So after interchanging, I'm getting 2, 3, 5, 4, 0, 2, 3, 4, 4, 8, 13, 12. So now the thing is, already the first entry of R2 is 0. So no need to worry here. I want to make only the first entry of R3 is 0. So what I can do, R3 implies that the row R3 minus 2 into R1. So if I multiply 2 for this complete row, I'll be getting 4 here. Subtracting this, I'll be getting 0, right? So the operation is R3 implies that R3 minus 2 R1. So I can keep the row R1, R2 as it is, 2, 3, 5, 4, 0, 2, 3, 4 as it is. I am applying the operation only with respect to the row R3. So subtracting R3 minus 2 times of R1. So I'll be getting 0, 2, 3, 4. So here the row R2 and R3 are same. So I can subtract very easily. So to make the complete R3 row 0, I'm going to subtract R3 implies R3 minus R2. So I'll be getting what? 2, 3, 5, 4, 0, 2, 3, 4, 0, 0, 0, 0. I got it. So as I told that in the non-zero entry, the first entry must be 1 always, right? So to make the first entries as 1, so in the previous matrix, I'm going to divide the R1 row with 2, R2 row with 2. So I'll be getting this matrix now. 1, 3 by 2, 5 by 2, 2, 0, 1, 3 by 2, 2, 0, 0, 0. So it is an echelon form having 2 non-zero rows. So hence the rank of a matrix will be 2. One more example. A matrix is given like 4 cross 4 matrix here, that is 4 0 2 1 2 1 3 4 2 3 4 7 2 3 1 4. So same thing here also. So the first entry, the first row of the first entry is very large here, so it is very difficult to perform the operations. So to make it as small, I can interchange any two rows. So according to the properties of elementary row transformation, we can interchange any two rows. So that for that, I'm going to interchange the row R2 with R1. So after interchanging the first row with second row, the matrix will be like this: 2, 1, 3, 4, 4, 0, 2, 1, 2, 3, 4, 7, 2, 3, 1, 4. I got it. So now I'm going to apply the series of the row transformations to get an echelon form. The first thing is always we have to convert the first entries of R2, R3, R4 row must be 0 here. So to make the first entry of R2 row 0, I can do operation like this. R2 implies that R2 minus 2 R1. So I can multiply 2 for this row. So it will be 4 here. So I can make 0 easily. Again, R3 directly I can subtract R3 minus R1. R4 also I can make directly subtract R4 minus R1. So after applying the series of operation, what I can get, I can keep the first row as it is, 2, 1, 3, 4. I'm applying the operation for R2 row now. The R2 implies that what? R2 minus 4 R1. So after subtracting, so 4 minus 4 I'll be getting 0. 0 minus 2 I'll be getting minus 2. 2 minus 6 I'll be getting minus 4. 1 minus 8 I'll be getting minus 7. Again R3 with minus R1. So 0, 3 minus 1 2, 4 minus 3 1, 7 minus 4 plus 3. Again R4. So R4 minus R1. So 0, 3 minus 1 2, 1 minus 3 minus 2, 4 minus 4, 0. I got it. So now the thing is like I want to make the complete last row as also 0. I mean I want to get an echelon form. So let me get an upper triangle matrix or make the last complete row as 0. So the one thing is I want to get an echelon form here. So for that what I can make, I can perform the next operations also. The next operation is like I'm going to perform R3 implies R2 plus R3. So to make the next entry of R3 0, I'm doing this operation. R3 implies R2 plus R3. I can make it because the entry is like this here. 2 plus 2 is there. So I can make the operation like R3 minus R4 implies R4 plus R2. I can make it. So similarly for R2 row also, R4 also, R2 plus R4 I can make it here so that I can get zeros. So now after applying this operation like for R3 and R4 row, so I'm keeping the R1 and R2 row as it is only. 2, 1, 3, 4 I'm keeping as it is. R2 also 0, minus 2, minus 4, minus 7 I'm keeping as it is. So now I'm doing operation with respect to this R2, R3 and R4 row. So doing R2 plus R3 I'll be getting 0, 0, minus 3, minus 4. For R4, I'll be getting 0, 0, minus 6, minus 7. So now the last thing, I want to make this one also 0 so that I can get an upper triangle matrix, I can get it. So that I can conclude that, so once we go to upper triangle matrix, it will be obviously equal to an echelon form only. So to make this one as 0, what I can make? I can make R3 implies that R3 minus 2 R4 minus 2 R3 I can make it, right? So since both are negative, I can use minus operation here. So 2, 1, 3, 4 I'm keeping as it is. R2 also 0, minus 2, minus 4, minus 7 I'm keeping as it is. 0, 0, minus 3, minus 4 I'm keeping as it is. Doing operation with respect to only R4 row. So what I can get? 0, 0, 1, right? Also according to echelon form, the first entries of the non-zero row must be 1 plus 1, right? So I can divide the first R1 row with 2, second row with minus 2, third row with minus 3. I'll be getting 1, 1 by 2, 3 by 2, 2, 0, 1, 2, 7 by 2, 0, 0, 1, 4 by 3, 0, 0, 0, 1. So once an upper triangle matrix I got it, so obviously it will be equal to an echelon form only, right? So this echelon form having 4 non-zero rows here. So since here 4 non-zero rows are there, the rank of the given matrix will be equal to 4. Thank you.